Today we're going to be talking about graphs, and graphs are pictures. And graphs are very important because people are hardwired to think and see in terms of pictures. Take, for example, all this information right here. This is a chart or a table, and with a little bit of work you could probably find a pattern in that information. However, if there's hundreds or thousands of data points like there are in real life, that's going to be a very difficult job. But if we take this information and change it into the form of a graph, very quickly patterns will become apparent, and we can actually even compare two sets of data at the same time. So graphs are extremely useful. Now, there are certain criteria that need to be followed in making a scientific graph, and that's what we're going to talk about with the remainder of this video. The first thing you want to do is take a sheet of paper, and you want to take a full sheet of paper. You do not want to end up with a graph that's up in the upper left-hand corner. You don't want a little thumbnail graph. The purpose of this graph is to communicate results to somebody else, and you want to do that in the easiest way possible. Secondly, you want that graph paper to be oriented vertically, if at all possible, because usually this is going to be part of the scientific paper. And as you're paging through the scientific paper, you don't want to have to constantly turn the paper back and forth in order to read it. As a last resort, go ahead and graph horizontally. But if at all possible, try to do it vertically for convenience. The next thing you want to do is determine which quantity are you going to plot on the y-axis and which quantity are you going to plot on the x-axis. Now, here we've got two quantities, temperature and rate of photosynthesis. Now, by convention, the leftmost column is going to be our independent variable. That's going to be the variable that a scientist purposely manipulates or changes. So in this case, the scientist is changing the temperature, and he wants to see how the rate of photosynthesis of a particular plant is going to change as he changes the temperature. The rate of photosynthesis is going to be our dependent variable because it depends on the independent variable. And in fact, the dependent variable is the thing that the scientist is going to measure. In this case, we're measuring the rate of photosynthesis. And the third column in this case, again, is a different data set, and we're measuring temperature, and we're going to manipulate the temperature, and we're going to see how the rate of photosynthesis of a second plant compares to the first plant. Maybe these are two different species of plants here. All right, so our independent variable is going to be plotted on the x-axis. The independent variable is always going to be plotted on the x-axis. So let's go ahead and write temperature down here. And I'm going to leave a little bit of room so I can, write my numbers for my axis here. So temperature, the unit is going to be degrees Celsius. So I'm going to write degrees Celsius and put that in parentheses. The units are very important. Is this Fahrenheit? Is this Celsius? Is this Kelvin? That's a big deal. Now, the dependent variable, in this case rate of photosynthesis, is going to be plotted on the y-axis. So the dependent variable is always plotted on the y-axis. So again, let's go ahead and write that down. Rate of photosynthesis. And I'm going to abbreviate just a little bit. Now notice I wrote that horizontally. Again, you don't want to write it vertically like this and have to have somebody turn the graph in order to see what your quantity is. So if at all possible, write it horizontally. And again, the units here is percent. The units are percent here. So we've got that. Now the next thing you need to do is scale your graph properly. If you don't scale it properly, you could end up with a graph that's way too big, or a graph that is down here in the lower left-hand corner and everything else is left blank. You don't want that to happen. So you've got to look at your numbers here. Let's take a look at temperature, which is going to be plotted on the x-axis. Temperature goes from 2 to 38. Now I don't have to start at 0 here, but in this case I'm going to. I don't have enough room to write 0, 1, 2, 3, 4, 5 all the way up to 38. It's going to take up too much space. So what I'm going to do is I'm going to break this up. I'm probably going to start at 0. So I'll write 0 here. And then I think I'm going to go by 5s. All right? All the way up to probably 40. I want to make sure that I include all the numbers here. So 0, 5, 10, 15, 20, 25, 30, 35, 40. Now when this is all said and done, my graph had better take up over half the sheet of paper. Because if it doesn't, that means I've got a scaling error. That means I probably could have doubled everything and made my graph much bigger and much easier to understand and see. All right? So I've used up over half my x-axis here, which is good. Now let's take a look at the y-axis here. My numbers, I'm going to look at my smallest number. I'm ultimately going to plot both of these sets of data. And my lowest number is 10, and my highest number is 80. So I want to be able to write from at least 10 all the way up to 80. And again, nobody said I had to start at 0. In this case, I'm going to actually start with 10. So I'm going to go ahead and I'm going to write 10 here. My origin is going to be 0 and 10. And I'm going to go by 5s, I'm going to try, all the way up to 80. So there's 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So again, did I take up more than half of the y-axis? And I did. If I took up less than half of the y-axis, again, I got a scaling error, and I could have doubled everything. I could have stretched things out a little bit more. There are computer programs that do this nowadays for you, but you need to be able to do it in your head. You need to be able to have those basic skills. All right, so now all we need to do is to go ahead and start plotting data points. So our first data point is going to be 2, 11, over 2, up 11. So I'm going to go over 2, up 11, so right about here, I'm going to put a little data point, big enough that you can see it, but not too big that it could include 10 other data points. And then I'm going to go ahead and I'm going to put a point protector. I'm going to put a circle around it to signify that it is a data point, that it's not a little smudge or a little dot on a piece of paper, because later on, this graph might be photocopied. And what if a little dot was to appear, a little black smudge or dot was to appear? Is that going to be a data point? How do I know if it's a data point or not? Well, the way I'm going to know is because I have a point protector around that data point. So let's go to the next one, over 6, up 14. So I'm going to go over 6, up 14. So right about here. And again, another point protector. The next one, over 10, up 16. Over 14, up 19. So right around here. Over 18, up 24. So about here. Over 22, up 32. So right about there. Over 26, up 40. So about here. 30, 55. 34, 75. And 38, 50. Okay, so over 38, up 50. So right there. So those are my data points. Now I have to connect these data points with a smooth line. Things do not happen at right angles in biology. So what we want to do is we want to connect up these data points with a smooth curve. And very important, make sure that your trend line goes through every single data point. All right? So I'm going to start here at the first data point. I am not going to start at the origin. I don't know if the origin is a data point or not. I don't have any information. So I cannot draw a line all the way to the origin. I don't know if there's a data point there. So I'm not going to start there. I'm going to start at the first data point, and I'm going to start connecting these data points with a smooth curve. And I'm not going to go past the last data point because, again, I don't have any information out here. Does this continue? Does it turn and go up? I don't know. So this is all I can tell right now. So this is my trend line right here. Very important. And very quickly you can see what's going on here. It looks as the temperature increases, the rate of photosynthesis continues to increase until a certain point where after that photosynthesis begins to drop off very quickly. At least that's what my data is telling me right now. The next thing we want to do is I want to plot this other set of data, and I want to compare both sets of data. Now it would be very easy for me to just grab another marker, maybe a green one or a red one, and plot that other set of data. However, if this gets photocopied in black and white, which oftentimes it does, then my beautiful colored graph is now black and white again, and I can't see distinctions as well. So what I want to do is when I plot my second set of data, I want to change the shape of my point protector. Maybe use a triangle instead. And I'm going to continue to use black here. And that way, even if I have a black and white graph, even if it's been photocopied in black and white, I can still tell the difference between the two data sets. So let's go ahead and do that. I'm going to go ahead and plot over 2 and up 10. All right, so over 2, up 10. That's going to be right on the line here. So there we go. And I'm going to put a triangle here. Just keep your shapes very simple. I'm going to use a triangle. And over 6, up 14. And I'm going to try to do that. Notice these 2 points are going to be the same. So what I'm going to do here is I'm going to draw a triangle over top of my circle. I can do that because this data point is a common data point between the 2 sets of data. Over 10, up 18. So I'm going to go ahead and do that. There we go. Over 14, up 20. So I'm going to put that there. Over 18, up 24. Maybe right there. Over 22, up 32. Over 22, up 32. So pretty close. Let's see, over 22, up 32, up 35. So it's just a little bit above that. Over 26, up 45. Over 30, up 60. Over 34, up 80. And over 38, up 50. Over 38, up 70. So right about there. And go back, make sure I got my point protectors around everything. Now at this point I'm going to go ahead and connect up my data points. And that is my second set of data. And I can tell the difference because this one has triangles, this one has circles, and I can take a look at both sets of data and compare them. Probably what I should do is this is species 1, this is going to be species 2, and I can write that down. This would be species 1. Species 1. This might be species 2. What I could also do, somewhere on my graph, if I've got room, I could make a little circle around a point, and I could put equals species 1. And a little triangle around my other data point and write equals species 2. Now the last thing I need to do here is put a proper title on this. And you just don't make up a title off the top of your head. It needs to be appropriate. So usually the title is in the form of the dependent variable versus the independent variable. Dependent versus independent. And our dependent variable here is rate of photosynthesis. So I'm going to go ahead and write that down. Rate of photosynthesis versus the dependent variable versus the independent. The independent variable is temperature. Notice two things here. One, I didn't write the units in the title. Usually you don't write the units in the title. And number two, the title does not go over top of my trend line. You do not want to interfere and put something over top of your trend line and obscure that. So make sure that your title is above the trend lines. Lastly, and I probably should have said this earlier, when I'm actually drawing the axes on my paper, I like to leave an inch of space to the left, to the bottom. And that way I have room to write my quantities and my units and my quantities and my units. Again, when you begin to draw your axes, leave about an inch of space here and an inch of space there. That way you're going to have some room to work with. And that's it for drawing graphs.